Hi, I'm Debbie. I'm Deborah. I mean, you can call me Debbie. I started this tech webinar series recently, and this happens to be the first episode. And I hope to put out more content that would help developers and DevOps engineers as well. For now, I'll be starting the webinar series with discussing DevOps related topics, and I'll be starting with getting started with DevOps. So let's get right to it. Yeah, so for today, I'll be covering continuous integration and continuous delivery, CI/CD. I'm talking about DevOps automation, I was talking about monitoring and logging and some popular tools used in DevOps. That's what I'm going to be covering today. Without further ado, I think I'll get right into it. So there are sets of practices in DevOps, including continuous integration, CI, that's known as CI, so it's like an abbreviated format basically, and continuous deployment CD. So it's called CI/CD, so continuous integration and continuous delivery. Yeah. So to explain what CI/CD entails, let me give you a vivid illustration. Okay. I guess the network is pretty bad, so I'm having issue with the image coming up. Okay, so let me see what I can do. Okay, so just give me a second, I'll be right back. Okay, so something happened. I kind of like lost a huge chunk of my slide, but I'll just go ahead with the presentation basically. So yeah, back to what I was talking about. So I'm going to be explaining what continuous integration and continuous delivery entails, and I'll explain it in such a simple manner that if you're new to DevOps or you're very if you're in fact if you're very new to tech, it's very easy for you to understand and grasp the idea behind the basics. In DevOps, basically. So I'll start by giving you a vivid illustration about a man named Mr. John. So there's this man named Mr. John. He's a businessman, and he had an idea to convert his store to an online business with the aim of gaining more customers and increasing profits. So Mr. John is not tech savvy enough to build an application all by himself. So he decided to get developers that can bring the application to life. Yeah. So what he did next was to hire a team of two developers named Sam, a front-end developer, and Debbie, a back-end developer, who lived far away from each other at different countries. Yeah. So they came together with their various expertise to build the application with an estimated time of 2 months. Yeah. So Debbie waited for Sam to write his own part of the code. He was writing the front end part of the code while she waited for him to be done with that before she could write and integrate the back end of the code which she was writing. So after that, after they concluded their part of it in the application, Mr. John hired a pro, to test the application while it was still in development environment, and a huge amount of bugs were discovered in both the front end and the back end of the application. So these bugs were reported back to Sam and Debbie to make the necessary fixes, which took an additional 2 months, making it 4 months in total, judging from the time that was estimated for the project. So Mr. John, as a result of all the delay and everything, it was quite frustrating for him, and he was quite disappointed at how much time and cost the whole building, testing, and integration of the changes took. So what did he do? He basically just waited. At the end of the day, it took almost a year for the application to become live, right? Because he didn't have a choice. Yeah. So do you know how these things are? So when developers build an application, there might be issues with the code after much testing, after much back and forth. There'll be a lot of back and forth, and at the end of the day, the estimated time of 2 months would take like a longer time, right? And as usual, the cost involved will also increase. So if an amount was estimated for the project, that amount will definitely not be what is spent at the end of the day. It's going to be what's going to be spent at the end of the day is going to be like so much, right? So later on, Mr. John found out a set of DevOps practices called continuous integration and continuous delivery, which he discovered was more productive and time saving, that could help automate the entire build, test, and integration process of the application regularly. So that I'm going to be describing and explain basically what this continuous integration means and how it actually saved Mr. John from the frustration and the disappointment he was basically facing in building this application, developing this application, right? So what is the continuous integration? So continuous integration is basically a practice that ensures changes made to the code of an application are integrated on a continuous basis. So what happens here is a team of developers working on a particular project can commit changes made to the application in a shared repository, and a build and test process will start automatically. So that's what happens here. So a shared repository, if you're a developer watching this, or if you're a developer that will watch this later on, I'm sure you're very conversant with, you should be conversant with the term repository. So I'm referring to a Git repository, for instance, right? So basically developers who want to working on the project to basically commit the changes made to the code base of the application in a shared repository, right? And once they do that, any commits that they make to the repository will trigger a build and test process automatically. So that's the whole concept of continuous integration, right? So developers can get a notification when a build or test process fails, with an easy way for them to quickly tackle the issue or quickly solve the issue. That's basically what I'm trying to say. So if going back to our case study, Mr. John and the two developers, Sam and Debbie, and the long time that it took them to develop this application, you would see that okay, they didn't have this method, right? They weren't using this method. So usually the whole process was manually, right? It wasn't automatic. There was no automation involved. So it took a longer time to, bring the application to life. And also if you've heard about the software development lifecycle, I wrote an article on it recently, and I'm going to add the link to the article in the description of this video once once I'm done recording here. So the software development lifecycle process is just basically the stages involved from the planning stage, design stage, and analysis stage down to the maintenance stage, right? Involved in the whole process involved from the time you have a business idea to the time you build out that business idea to the time the application is live and all of that. So those processes involved from the building to the testing and everything usually will be handled manually, but with continuous integration, the whole process can be automated, right? So that's basically what I'm trying to say. So continuous integration comes with its own benefits, comes with its own advantages, yeah. So we have one of them is minimized manual labor. So like I said earlier, when using a continuous integration method, the manual labor involved would be lesser. It will be so minimal, right? Allowing the developers to focus on more important tasks, right? Or tasks that are highly, the attention is basically, I think the better way of putting it is allowing developers to focus on less repetitive tasks. Yeah. So CI or continuous integration basically just makes those repetitive tasks automated basically. So by minimizing manual labor, I mean is the continuous integration makes use of tools that automate the build, testing, and integration process that would otherwise have been done manually, right? At the end of the day, using this kind of method, this automated method, would mean that the speed of the development process would be, increased, right? Obviously, right? So there's another benefit that continuous integration offers, which is faster identification of bugs. So referring back to our case study, if Mr. John used a continuous integration environment, the issues in the code would have been detected earlier and in turn fixed in a shorter time frame. Yeah. So the situation where Sam, the front-end developer, would according to him, finish his own side of the application, right? Finish building his own side of the application with the framework or whatever programming language, let's say JavaScript, right? And then he's done, and then the tester does her work or his work, and then at the end of the day, a lot of bugs, right? At the end of the day, the time to take him to fix this bug wouldn't make sense, because at the end of the day, if Mr. John wanted the application to be live, or if he wanted to start the marketing of the application, let's say in March, and it's the whole building process started in January, at the end of the day, it's going to take a longer time, and at the end of the day, he might end up just waiting till December till everything is done. So there's continuous integration basically allows developers easily identify bugs, and not just easily identify them, but attend to these bugs, and they'll fix the issues very fast, because the whole process is automated. Yeah. So there's also automated integration and testing. So if the building of the application was done in a continuous integration environment, the code changes made by Sam and Debbie would have been integrated and tested continuously without them having to wait for the entire software development lifecycle to be completed. Then there's also fast delivery. So the time it took the application to be released would be shorter in a continuous integration environment. Yeah. Then there's also increased collaboration. So as mentioned earlier, a continuous integration environment fosters much more collaboration between the team of developers working on a project, as they leverage a shared repository, right, that automates the whole building, testing, and integration process. So there's increased collaboration between both Sam and Debbie, if that makes sense. So far I've been talking about the processes involved when the software is still in a development environment. So what about a situation where the software is already in production, but let's say a malfunction or a bug is discovered and needs to be tackled without causing downtime or without affecting the application's performance overall? Or let's say another situation where the company decides to add more features to the application without affecting the user experience. What then, right? Good question. So DevOps also has a solution for this. And I'm going to talk about continuous delivery, which basically hammer on the fact that or prove the fact that DevOps actually has a solution for these questions I just asked. So what is continuous delivery? Continuous delivery, on the other hand, is another DevOps practice, just as you have continuous integration, but this time around, it deals with automating the process of quickly delivering software changes to production without affecting the running application or the application's performance. So, the continuous integration I just finished explaining, basically, was all about the changes that happen within the development environment. So if you're a developer here, or you've heard about, obviously you should be a developer. I mean, like, if you're interested in DevOps, you should have some basic understanding of development, right? So, or programming, right, or how it works, or basic how, or yeah, basically how computer programming works. So you should know that, okay, when you're building an application, it has to be start from the development environment, right? So you're building an application and it's in the development environment before it gets to the production environment. So the continuous integration has to do with automating all the processes that happen or occur within the development environment, while continuous delivery now has to do with automating all the processes that have to do with quickly delivering software changes to production. And as it does that, without affecting the application that is already running. Because when I say an application is in production, what I'm trying to say is, okay, this application is live. Users are using it around the world, or let's say in a particular region, or whatever. But they have users of the application. The application is already live, it's in production. But this time around, you see an application that is in production, but it has a malfunction, which could affect the user experience. And then the let's say the company, or let's say in this sense, or using our case study, Mr. John noticed that, okay, my application is not working right, or my customers have complained that this feature, this application is not working right. So he reaches out, because he's not tech savvy. He reaches out to his developer Sam and Debbie, and he's like, okay, can you guys check this out, because this is not working. Now Sam and Debbie would have to make changes to the code base, and that would mean, if they aren't, for instance, they aren't using a CD environment, that's a continuous delivery environment, it would mean them almost restarting the software development lifecycle, or it would mean them making a change that will affect the application's performance. Or doing all this in a continuous delivery environment would mean that whatever code changes that Sam or Debbie are making to the code base in that shared repository will be automated, and the users would literally feel no effect, right, on the application performance. That's basically it. So I'm sure you may wonder how this works. So I kind of like explained it, but I'm still going to like emphasize on it again. So basically what I'm saying is, what happens in a CD environment is that the code changes are automatically built and then tested before being deployed to the production environment, which is cool, right? So I kept mentioning that basically I kept hammering on the fact that, okay, the developers will make some code changes, right? But then those code changes they might make might lead to more troubles, might lead to more bugs. So these code changes that they need to go through the due process of testing, yeah. So that testing also is automated within the CD environments. Do you get? So both CI and CD work hand in hand to deliver reliable and high quality software. So just as we have continuous integration offering a set of benefits, we also have continuous delivery offering its own set of benefits, and some of them include increased customer satisfaction. So a CD environment basically enables software changes and new features to be released faster, which will lead to customer satisfaction. So I kept talking about, making code changes as a result of a malfunction. It couldn't be. It might be that, okay, Mr. John would like to add more features to the application, right, to maybe improve the user performance, or maybe get more profit on his business. So he reaches out to the developer and be like, okay, please can you implement this functionality? And then developers can put their heads together, okay, think about how they can make this better or make that better. And then they want to, introduce a new feature, right? Introducing a new feature would mean like I don't know how to put this right now, but if they are doing this in a CD environment, it would not affect the application performance basically. So they will be able to introduce a new feature, and not just introduce a new feature, the time that it will take for them to introduce that new feature to be released faster would be shorter than doing that manually, basically. So there's another benefit of that CD, that's continuous delivery offers, and that's reliability. So the software that depends on a CD environment requires less manual labor, like I said earlier, and it reduces the likelihood of bugs and ensures that the deployment of the software changes are consistent. So that's another major benefit of using a continuous delivery environment. There's also improved marketing time. So since new features are delivered faster, it means that it takes lesser time for companies to market new features to their customers, which I kind of like said earlier. Then it also reduced cost. As most of the deployment process are automated, the money spent on manual labor is highly reduced. So that's like a very important part because money is scarcified these days. So nobody wants to just throw money around. You get so using a CD environment will make the whole cost of the whole development cost and production cost and all the testing costs and everything to be minimalized basically. So we have types of CI/CD tools in existence. We have like I said earlier, continuous integration and continuous delivery will basically not be possible without tools. It's basically made possible with tools, and these tools exist. I don't know if you've heard of some of them, but I'll list a few. So we have Circle CI. There are many of them existing, but I can't like list the popular ones that I know of, and I've probably worked with in the past. They have likes of Circle CI, Jenkins, Azure DevOps, Travis CI, GitLab CI/CD. So these are all CI/CD tools that help automate the whole development and production process and deployment process for developers and for someone like Mr. John. So, okay, enough about CI/CD. I've mentioned automation several times, and you may be curious as to how DevOps automation works. So, let's talk about DevOps automation quickly. So, what does automation mean in DevOps? So, from all I've said earlier, automation in DevOps simply means utilizing tools for streamlining the processes involved in the software development lifecycle. So, if you're just joining, I said I'll link a link to an article I wrote on software development lifecycle in case you're curious about what it means. Yeah. So basically, automation in DevOps is simply utilizing tools for streamlining the processes involved in the software development life cycle. So there are tools used to automate the testing process, and we have tools such as Selenium or Selenium. I don't know if I'm pronouncing it right, but it's spelled Selenium. Sorry about this. My presentation slide, I actually took my time to prepare something very nice, and I don't know what happened, but I don't know, a huge part of my presentation is gone. So I'm literally saying everything off my head right now. So it's fine. I can't forget what I've said because I literally created the presentation slide, so it shouldn't be that hard. So back to what I was saying. So we have testing processes tools that can be used to automate the testing process, such as Selenium. Jenkins also used for automating testing process. I mentioned Jenkins when I was talking about CI/CD tools. There's also Test NG and there's JUnit. And there are more of them. You can just Google examples of or tools in existence that are used for automating the testing process, and you see a huge chunk of them online. So, in simple terms, DevOps uses a set of tools to automate the repetitive and time-consuming tasks involved in the software development lifecycle process. So next, I'll discuss other terms you need to be familiar with when getting started in DevOps, these terms include monitoring and logging. So if you're new to DevOps or you started learning DevOps, I'm sure you would have come across this term, monitoring and logging. And if you don't understand what it means, I'm going to explain it to you right now. So when an application is built and deployed to production, it doesn't just end there. Like I know some people who just like, okay, all I have to do if I have a business idea, all I have to do is just get developers or I build it myself, deploy it to production, and that's it. I'm good. I'm going to make tons of money, and that's it. No, it actually doesn't end there. It's important to pay attention to the performance of the application, or in other words, monitor the health of the application. Yeah, I said health. So the application can be sick. Yeah. So so when you monitor the health of the application, you're doing this with the aim of identifying any issues that may arise. So as users, or even as the number of users of the application grew, or as your application scales itself, the application can encounter issues, right? And if you don't tackle those issues as soon as possible, it may affect the users of your application. At the end of the day, business will become bad for you. At the end of the day, your application will be long gone or something like that. Or you might even experience application downtime. The application can just go down. Do you understand? So the process of doing all of this, monitoring the health of the application to identify any issues that may arise is termed monitoring. So that's what monitoring is. So simple, right? It's basically what the name implies, monitoring. But this time around, you're monitoring the health of, you're monitoring the performance of your application to identify any bugs or issues that your application may be facing. So when the issues are identified, they need to be documented. So not just you don't just identify the issues and just leave it there. You need to actually record these issues, and you're not just recording the issues for recording's sake, but you're recording the issues for analysis purposes. And the process of doing this is termed logging. So that's what the logging means. Like you're basically just recording the issues that you may have identified in the performance of your application, and then for analyzing these issues. That's what the login is. So it is most effective and best practice to carry out monitoring and logging in real time. So monitoring and logging cannot just be done manually. It's best practice and most effective, like I said, most effective to do this in real time. And doing this in real time would mean manual labor is limited, right? You can't just use manual labor to achieve this in real time. So you have to use, you have to automate the process of monitoring and logging with tools that are in existence for this purpose, such as Prometheus, Grafana, I think New Relic as well. So those are tools that you can use to automate the process of monitoring and logging for an application. And these practices basically are carried out in DevOps. If you once you get into DevOps, you're going to be doing a lot of these things. Yeah, you're going to be using some of these tools like Prometheus, the very popular tools. You're going to end up using. I don't know if I'm pronouncing it right, but I'm pronouncing it in my Nigerian tone or whatever. So, lastly, I'm going to just list out some popular tools used in DevOps. So, there are certain tools that you come across and use in DevOps. Some of them include Docker, Kubernetes, Ansible, Jenkins, Git, source control, and all of them. You're going to be using those tools in DevOps, and you can just take out time to look at them, study them, and the future videos that I'm going to put in now, I'm going to be like going deep into these tools and actually using them to build stuff and create pipelines and all of that. So yeah, I think I've come to the end of this session. It was actually very short because I wanted to be very short and precise. And so far, what I covered basically, I think I'll just go back to my agenda. Yeah, my agenda screen is still showing, so thank God. So I have what I covered basically in this session was continuous integration and continuous delivery. I kind of like explained it by telling you guys a story about Mr. John and the two developers, Sam and Debbie. And I talked about DevOps automation, how it works in DevOps. I talked about monitoring and logging, how it works, and some of the tools. I also listed some tools that I used to achieve CI/CD and tools that I also used to achieve monitoring and logging. And also tools that I used to achieve testing in automated testing. And I also just listed out some popular tools used in DevOps. So you can take out time to actually research on these facts and you'd be on your way in getting started in DevOps. So I think I've come to the end. So my name is Deborah Emini. I like being called Debbie. I don't know why, but it's shorter. So Debbie, you can follow me on Twitter. I would add. I think I'll add the link to my Twitter handle in the video description. I think it's time for me to like check the comment section, see if there are any questions. So if you have any questions regarding what I asked, you can just ask in the comment section and I would answer. Okay, someone is asking, fashion addict, asking how can a person become a DevOps engineer? Any roadmap? Okay, so hi, fashion addict. I think you can message me on Twitter. I think I'll just drop my Twitter handle right away, just so that you don't miss it. So you can message me on Twitter, or rather, I think I'll send you the handle for the DevOps Learning Space community. We currently have a learning curriculum, and we have like a roadmap and a learning curriculum, so you can send a message. I just posted the link in the comment section, so you can take a look at it and just send a message to the DevOps Learning Space, and we'll add it to the community. Send your email as well, so we add it to send you an invite, and then you can get an answer to your question. For small scale applications, yeah, sure. I don't think there's any limitation. I mean, like if it can be used for large scale applications, definitely should be able to handle small scale applications. So yeah, so I love to keep to time. So I think I've come to the end of this session. Thank you guys, everyone that attended, and those that would watch this video later on. Please look forward to my other episodes in my tech webinar series, and I'll be discussing a lot about DevOps in the future. See you guys later. Bye.